Hello, and welcome to the presentation on smart antennas and how to make them smarter. My name is Luis Menduinas, and my team member's name is Shirley McGee. So, what are antennas? As studied in class, the antennas are interfaces between two waves that are traveling. They transmit signals, and there's usually a configuration of one or more of them in between the transmitting and receiving channels. There's various configurations of antennas that we've spoken in class, and we'll be talking a little bit more about the ones that we will be focusing on this slide on this presentation on a later slide. Okay, so what is smart technology? Smart technology is actually nothing new. It was actually invented in 1999 by a scientist named Kevin Ashton when he tried to categorize different mass production devices utilizing RFID. This technology has seen a recent surge in the recent years and was made modern through networking and added layers such as the connectivity and the network layer, which are the ones in interest when we're talking about antennas. The root of IoT, or the Internet of Things, and smart technology lie on sensing and actuating. In today's world, just simple sensing and actuating is not enough, since there's a large amount of data, so there needs to be a smart type of logic and intelligence behind each device that can make smart decisions on the fly to be able to make these systems more efficient. At the same time, large amount of data needs to be transmitted and crunched in almost real time to make the smart technology environment function.
A smart antenna is an antenna system that is digitally wireless, contains multiple antennas, and digital signal processing procedures. These procedures are responsible for very critical functions such as calculating beamform vectors and direction of arrival of the signal. Smart antennas can improve data speed and decrease the error rate. Smart antenna usually falls into three groups: SIMO, MISO, MIMO. SIMO, which stands for single input, multiple output, uses a single antenna that transmits and multiple antennas that receives. MISO, which stands for multiple input, single output, uses multiple antenna to transmit and a single antenna to receive. MIMO, which stands for multiple input, multiple output, uses multiple antennas to transmit and receives. Two of the main types of smart antenna includes switch beam smart antennas and adaptive array smart antennas. Switch beam consists of either a number of fixed beams with one beam turned on towards the desired signal, or a single beam that is steered towards the desired signal. Adaptive array adjusts its antenna pattern to enhance the desired signal while avoiding or reducing interference. This slide shows the comparison between switch beam and adaptive array. Switch beam is easy to implement and has low cost, but has less coverage compared to adaptive array and has low interference rejection, meaning it's difficult to distinguish between desired signal and interferer and do not react to the movement of interferers. Adaptive array has more coverage, high interference rejection, and reduction in power, but it's more complicated to implement and has a high cost. This slide shows how a basic smart antenna system is designed, with switch beams, antenna array options, and single multi-beam directional antenna and single multi-user beam forming.
Okay, so what role do the smart antennas play in this whole smart city technology? Well, smart antennas are a component of the IoT world. They communicate with each other and they make smart decisions based on the environment they're found in. In smart cities, antennas can sense the smartest array for the situation they're in and adapt to send signals more efficiently with less data loss. Furthermore, not only are they a component of IoT, but they're also part of the networking layer and they can be utilized to send signals in between other IoT devices. So the way to picture this is in a smart city you have two smart antennas and they communicate with each other and they're being smart, but um, generating different beamform patterns and different power strengths. But in addition to this, they're also part of the networking layer, and they themselves are used to carry out the data between the city and the server or the city devices within themselves in order to create this IoT smart city. What are the potential capabilities of smart antennas? And mainly one of them is energy saving. Not all the signals require the same amount of data. For example, if you're just going to be sending a small Bluetooth signal, you don't need high beamforming, uh, strongly powered signal in order to get it across. You could keep these resources free and thus save some energy and send a lower power signal. The other one is smart beamforming. It's similar to the other one. Is basically to beamform or not to beamform to keep the resources available for other antennas and being able to create different configurations of antennas for beamforming in order to be able to create different systems and use the resources effectively. Also, variable antenna arrays, which were mentioned earlier, it has the same idea, creating different arrays and being able to subdivide the arrays as need be in order to create different systems and maximize range and bandwidth. And lastly, adaptivity for the subnetworks in smart cities. Smart cities will have different networkings such as Bluetooth, 802.1, and other types of signals that need to be sent. And these antennas need to be able to adapt to be able to communicate using the various signal types. Okay, so how can we make these antennas smarter? What will be the future of them in smarter? And one of them will be real-time communication. This will be not only between each other, but between the server to see the needs of the server and the needs of the antennas and other devices. Um, they need to have real-time communication in order to be able to create an error system and optimize signal strength. Furthermore, there will need to be a configuration adaptability. This has to do a little bit with the previous slide, having to do with utilizing a signal that's 802.11, Bluetooth, and other signal types, and being able to adapt to whatever the device needs, and on the fly being able to change signal types that the antenna is utilizing to transmit in order to maximize, again, efficiency and decrease data loss. Speaking of data loss, that would be the last thing that I would include in how to make these antennas smarter. Um, the systems need to be able to check whether the data loss is at play and compensate to improve signal connectivity. Basically, the system needs to have some type of live error checking in order to see, okay, well, am I losing data? Do I need to add more antennas into the array? Is one of the antennas failing? Do I need to make up for this one antenna failing by adding another one to the array? This on the demand and on the fly type of error checking will create an efficient system that will have higher uptimes. So in this presentation, we talked a lot about antennas and IoT and just how they have up to now. Antennas will continue to be a large part of our future when it comes to connectivity and the development of IoT and smart cities. They will lead to a smarter connectivity. We spoke about how their configuration, their strength can be varied in order to maximize connectivity and decrease error. They need to be able to adapt in real time and match the ever-changing needs of our society. Antennas themselves, we talked about two types of them. We talked about beam, switch beam, and switch array antennas, which provide two different types of antenna types that can create different systems. And we spoke about how in smart cities, the large need of large data crunching and how these smart antennas that utilize the resources effectively will become a must. Thank you, and if you have any questions, please post them below. That way we can get back to you guys.